like this side better. So if you guys look at your at our Canvas page for this class, meeting 1 was last class. So this was the these are the PowerPoint presentations that I followed last class. This is the entire checklist that says you need like a close to choose and things like that. And the safety data procedures is actually this document that you have. And the meeting number 1, if you click, then it's just me talking exactly what I talked last class. And then today, so this is how you kind of navigate. So we're recording the video right now. The link is gonna go right in here, and we have like a couple like drawings that we're gonna talk about today. Right? There's no PowerPoint presentation for today. All right. So just look at the first one. So this was last year's project for the vertical mill. It might be a little different this year, just because we changed like how the setup's gonna be. Last year, you spent all the labs or all the meetings that you were in the vertical mill, making all the cuts, so you finish with this piece, right? Everybody comes in and take one pass. So now we're changing. You go in there, you finish a whole project in one day. You come in and they follow it like in a different day, you finish a whole project in one day. So you have to remember all the things. But like this is the project from last year, so it's gonna be something similar, but not an exact one. So we're gonna upload the drawing as soon as we have it. But this is a mechanical drawing. So a mechanical drawing it's like a contract. You have to specify everything that you want on your piece or how you want your piece to look like, right? So we are still planning to actually give you guys more information about how to add more details to make it more like there's more clauses of the contract. However, the tighter is the contract, the more expensive is the part, right? So we are gonna start talking about tolerance. Like, does anybody know what tolerance is?
Would it maybe be just how much, like, air room you're in?
Yeah.
Or-
So like error mean like for example, this one specify a tolerance, right? Right there.
Yeah.
So what does this mean?
You can be within 1.02 and 0.98.
So anywhere in there that you land is good. It's a goal, right? Anywhere that you land in here, it's a goal. So like if you tell the guy 1 plus or minus 0.02 and he gets to 0.02, he's not gonna try harder to actually achieve the 1.00, right? Because he's within the range and he's fine. He's safe. So, but there's a problem with that, right? We have to understand what is limits that we want to put on the tolerance limits that we want to put on the block. Because imagine like this block is actually going to fit in a keyhole. So what's the limit that you want to put in the keyhole then? Because that block goes in here. So this one, can I do 1?
No,
Why not?
because it could be too big to fit in there.
Because this one can be 1.02. So usually when you're coming up with all this things like there's a lot of thought that's given into, okay, what's the max gap that I can have in there, right? Because I don't want it to like too tight, but I don't want it to lose either, you know. So like that's where engineering and testing engineering kind of comes from. Like you have to actually get all this figured out even before you. All right. So what about all these other things? What's the tolerance for those ones?
No tolerance.
No, everything has a tolerance. Like if you say, I want something that's like a 1.000000000, it's still gonna be plus or minus 0.00, and it's gonna have the same number of zeros. 1. Like, it's actually possible to make it perfect. Like, the more zeros, the more expensive. That's what I said. Like, the more, we said about the more clauses, then. But
Is it 1,000?
so
Is it 1/1000 or is it?
no. So
Or-
the
Is it the amount of decimals that are there?
in every mechanical drawing, there is a standard block that talks about all the tolerances are, and the ones that are on the drawing right here is because they don't follow what's in there. See,
I see.
here it says if you have point X, then the tolerance is 0.1. If you get point XX, that means like two decimal places, then you get 0.01, and so on. And you might have if it's an angle, then 0.3 degrees. So you're gonna add all your tolerances in there, and whatever you don't want to follow, then you come and you put it in here, right? And you guys did that, right? Like on at
Yes.
ENR 200 last semester, last year. All right. But then there is something that's weird about tolerance. So I just talking about tolerance, right? So if I say this, so this guy can be 1.02 and 0.98, right? Tolerance. Who can tell me what a measurement error is? If PK is running in the labs like I used to do, there is a lab that you do error, and you do calculations in error propagation. Who can tell me what an error is? So even though it's called error, it's actually not a mistake. It's not a mistake. So the measurement error is, imagine I give you a ruler and I give you this pen. And the first student comes and measures and he says, "Ooh, I think that this is 3 inches and a quarter." And I give to the next person, and this next person says, "Oh no, it's not like 3 inches and a quarter, it's actually 3 inches." It says 5/16. And then I give to the other person, and the other person says, no, it's actually 3 inches and 3/16. Which student is correct?
Well, does it depend on like how precise your ruler is? Like the.
But which student is correct? You have the ruler, you have the pen, and the lines are like this. So the answer is all of them. To a certain point, like if somebody comes and say 4, then he's wrong. Then that's a mistake. But this is just considering that the person is actually doing a good job at reading the thing, you know. Because you always have when it's if we zoom in here, sometimes this line and that line, they're so close that actually it's pretty difficult to actually tell exactly where it is. Or it can be kind of what if it's actually right in the middle? You still have to call it one of you can't call the middle. You have to call either one side or the other side. So to actually take this in consideration, and everybody gets the same measurement, then that's why you have the measurement error. So this guy, how would this be written then? This would be written 3 1/4 plus or minus. So that takes that one and this one into consideration, right? And as it was said, it has a direct relation to the smallest grading of whatever you're using to measure, right? So that's why you shouldn't measure, you actually have to choose wisely what you're going to use to measure something, you know. So the way that you write this and you write this technically is the same, even though those are two completely different things, right? But there's one more problem with those, with those two things. Let's go back to this one, the tolerance that we have here. So I get this piece, and I decide to measure, let's say, with a caliper, and for some reason my caliper only measures with 1 decimal place, right? So that's the precision of my caliper. Or let's say, instead of measuring with a caliper, let's measure with a ruler. Because that's the precision of the ruler, let's say. So I'm going to put my ruler here. Let's make it a ruler then. So 1 is here, and you have 0.99, oops, 0.9 and 1.1. Does this work or not?
No, because you don't have a precise enough measurement.
Yeah, because like if one guy calls it 1.0, but it's plus or minus 0.1, there's a chance that this thing is actually 1.1. And 1.1 goes over, is actually bigger than my tolerance. So then we can use this tool. Right. So there are several things that actually they mess up with each other. Like first is actually the same writing, like the same way that you write. Second is one has a relation with the tool, the other is whatever you want on your part. So you have to make sure that's used correctly, right? All right. So this is tolerance versus and measurement error. All right. Now let's go back, and we're going to keep talking about it, but we're going to talk about not a measurement error, but now we're going to talk the mistakes, the problems that we can, things that we can do that's going to mess up with our reading. Let's say we're always going to use a caliper to measure this, right? I think we should look at a caliper. All right. So, in order to get the best measurement, so the caliper has the jaws, and we kind of have to make sure the jaws would actually seat as perfect as possible with the two sides, right? However, sometimes the chance of this happening is pretty low, because like what if this is actually bumpy? So one thing is, you have to try to make sure you are touching both sides and you are at a good position. So you are trying to represent whatever dimension you're trying to measure with your caliper the best way. And then after that, so now I'm 100% sure that this is sitting correctly, right? So are we good now? Let's say again like a 1.02 on this one. Am I good? Is it a pass? Depending on the so like there's a bunch of things that we haven't talked about yet, but so I just said that this actually was a rough surface, right? So what if I actually move around and I measure in a different way? Let's say I get this guy, and instead of putting in this axis, I put it in this axis. And then now, I get one extra bump that I wasn't getting on the other one. Because it's actually down here. The caliper only went up here. Now this guy is off. It doesn't fit my keyhole anymore. Right? It doesn't go in there. So a good use is actually you take a couple of measurements, especially on the parts that you feel like, these parts are like I can see that's uneven, or you take a few and then say, let's get an average, right? But all these things, like let's say, there is a way that I can come on this document and I can say the finish has to be like this or like that. Or we can say the roughness on this surface has a specific, has a specification for roughness. So that's when we come up with all these details. And for example, in this one, we actually added all the details. They want to talk about on we added all the details right there for this specific part. But depending on what you're doing, then you might actually need even more details just to make sure. Because whatever you write on this contract, the supplier can give it to you, and now you have to pay. So even we had when Dr. Carrico created this drawing, and he had this line, remove all burrs and sharp edges. We had a machinist that actually was working with us, and he wasn't very happy with that line. He was like, you're considered that we're not smart. Of course we're going to remove all the burrs and sharp edges. But until you put that line there, I don't have to. You didn't say. So that's the thing. You actually want to have everything in there. However, the more things you have in there, more expensive it is, right? Then you have one extra process for the supplier to go through. So one more process is one more person. It's a little bit more time, right? All right. So let's look at some details that we have here. Let's say this one. Who can tell me what that means? That's an easy one. Maria?
Is it just like when you measure it, there's a 0.02 tolerance?
No. Sorry. What do you think? What do you think this is?
Is that parallel?
Yeah. So this guy is talking about
Or look like a block?
parallelism, right? So what does it mean? There's a parallelism there.
To the
It's
bottom.
a parallel to B.
To B. So now you look at B. Where is B? B is right there. So between this surface And this surface, you can only be off in parallelism by
It was pretty easy.
30 thousandths.
Does that mean this way?
So that's parallelism, but so like and then here we're gonna talk about the center of this guy. If you look at A, B, and C, you can only be off by this much. You know, and we have all these different kinds of. So parallelism means this, right? So it has to be parallel. What's another problem that we can have in between those? Let's try to pick something up. Let's see. Details that can be added to mechanical drawing. That's the one that we did. I want to see more. I don't want to see parallelism. That's the one that we already know. So, what if we have this? That piece has to be parallel for a reason, right? Let's guess a reason. Why would you need these two sides to be parallel? Let's say that this block
It's different lengths.
goes in a hole, right? So that block goes right in there. You put it in there, right? So that's why those sides need to be kind of parallel. What if it's like this, your surface? Is it a problem?
Yeah.
You measure, and the max here is actually 0 point like this. The max. Does it fit in there?
No.
We can be up to we could be up to 1.02, right? It's 101. But like the surface is not.
It might be too little.
Does it work? It might work. If you don't want to be like a watertight, you know, if it's not like a this might not have any problems, you know. So you can say what's the flatness of this thing? Does it have to be flat? Right? So flatness and parallelism, they're not the same. So all these details, as I said, we can actually, there's a ton of different things that you can add in there. Usually when you're creating a drawing, you don't create a drawing from zero. You just like go and you see all the drawings that you already have, and then just update them, right? But usually, you can go like a very deep into the rabbit hole and make it very tight, or you can be kind of sloppy, right? The tightest, the more expensive, right? It's all about the process. So like, if you want, I can actually take another pass here and make this perfectly flat and shiny and this and that. But that has a cost, you know. It's more of my time. So that was the parallelism. Flatness. Now let's see if AI is smart enough to guess what I'm thinking. GD&T inspection. So
Is this development manager? Hiring for your small business? If you're not looking on LinkedIn, you're looking in the wrong place.
In this video, I want to chat about the difference.
let's see. Let's see what the guy has there. Yeah, I hate to talk.
He's a yapper. What a yapper.
Alright. So see that has like a block on the bottom? And in there we have a block just like that one. It's like if you consider that it's a perfect flat surface, don't hammer the block. Or it's not going to be flat anymore. But we can come on this block, and we can put our block. And can you see like this needle here? This needle has a gauge connected to it. And when you move the needle, the gauge will turn. So you can actually touch right on top of it, of your block. And then you can move your block around. And you can know the minimum difference between all this, but let's say, what would this thing tell you? That's our block. This is our stand. That's our thing with the needle. The needle's right there. This is what we want to consider we consider this a flat surface. We move this guy around. This is actually sitting on the same flat surface, otherwise it doesn't work. We move this guy around. If this needle doesn't move, that means that this is flat. Or if I move the needle in this direction and it doesn't move, but I move the needle in this direction and it changes, then what?
There's a bumper of it.
Then your thing is like this. Right? I'm moving I'm moving in that direction and nothing changes, and I'm moving this direction and it changes.
Does the needle go both ways?
Both ways. And you go around too. But you'd want to actually not see it in or you can move it and the needle goes like this. That means your surface is not is rough, you know, it's all like a bumpy.
Yeah.
All these things we do have this, and we're gonna have you guys using it too. Because for us, we are gonna try to add a GD&T inspection crash course for you guys in this course. You know, those videos that you guys watch when you guys are not off. You know, time of class, but we're not in the lab. So we're gonna try to add a GD&T. Because I think, I don't know if I said it in this class, but usually a school would have two different degrees. One that's a mechanical engineering degree and one that's a manufacturing engineering degree, right? But for us, you should be able to do both. So some of these details they'll never talk about in a mechanical engineering degree program, just because what they want people to be a design engineer. So they don't even know. Sometimes they don't even know that this exists. You know, they don't go in the shop and do stuff. You know. All right, let's see what this guy is gonna do. You know, he's gonna talk too much.
What a nice guy.
Is that the same guy?
When you're an annex school card member,
It's the same.
there's a
He's got his hair.
He talked the whole 8 minutes.
All right, let's try to
And he
see.
did the actual thing for 30 seconds.
And this is him too. Okay. Let me grab some.
All right. Let's see.
Oh no.
What are those, Michelle? What is this one? Have you seen before? Michelle? Have you seen this one before?
Yeah, I mean, in design GD&T course, we've got the, I think that's a profile of a surface, that's called.
So profile. There's another one here. See, and usually the GD&T course would actually point out all these different things that you can try to constrain in a mechanical part. So when you send to the supplier, he's gonna look at, this is what I need to do. You know. Good stuff. So for us in the lab, we're just gonna do something basic. But we're gonna try to add some content for you guys to actually learn more on the side. Just because sometimes each of these things, you need a different tool. So be able to try to measure and see if it's within range.
Does that triangle mean anything special?
The triangle, I think the triangle is talking about the center here, the center line. And actually the 3, it might be connected to a view.
Oh.
Because he only took a one piece from the drawing. See?
Yeah. Different. Oh, like the front.
Like if it was cut.
He might have this cut in a different.
Yeah. Makes sense.
Alright. So let's see. We had to talk about tolerances and measurement error. What is this? And quality check. Alright. So for you guys, what we're going to require from you, you are going to come in, you're going to make the cuts, and then you're going to take, and then you're going to take the measurements, and then you have to turn in what do you think the measurements are in your block, and then we're also going to grade you based on how well you took your own measurement, right? Because that's we feel that that's important for you guys to know. Like if you don't know how to take measurements, then you have one less skill, I guess, right? So but yeah.
Next question.
Sorry, I was just wondering, so I feel like something I would do is like I would cut it right or whatever, but then when I had to sand it down, if it was rough, I would go like lower than the tolerance was supposed to be. So do people ever like over measure to kind of account for when you're sanding it down? It's gonna take off material or not really?
Like what does over measure mean? Like you try to improve on your part so it falls within the tolerance range.
Kind of like on the last one, if it was like 1.02 was the highest it could be, would you ever measure over that and then account for when you sand it down, it'll be less than that?
It depends, but that happens. So sometimes imagine what you have to do is a 1.001. So 1.0, let's 1,000. 1,000 is actually like for us is actually we can do it, but it's not easy. So the smartest way for us to do this is actually to cut something at 5,000 maybe, and then now we polish until we actually get in the range. So that's why the more precise it has to be, then the more expensive, because now maybe the process that I have to add is actually a difficult process. So it can actually be, so technically to save money, you would want to have as sloppy as possible. So that's why you have to understand all the boundaries and be able to make sure it's all, or like sometimes you get like a piece that's like this, a piece that's like that, just because like from, let's say that from simulation, you can't tell the difference. So you have to get the real piece, and then you get the real piece, and then now you take it to the lab, and then you test it, this one is fine, this one is not. So usually have like a few samples just to know. And then you say, we thought that this was going to be a thing, and this is not, And some problems you only notice after you also put in the production line. So let's say you design all this, it looks good, made out of aluminum, right? And the guy has to mount it in the tractor, and then you take it there. So it's perfect. Like it's cheaper because it's aluminum. It's lightweight, so it's better for shipping. All this, and we're gonna save money, right? Everybody's happy. Everybody wants to save money. And then the first tractor comes back. It's leaking gas for some reason. And then the second one, and the third one, and the fourth one. And they all have this aluminum part. It's like, man, but I tested it, We tested like a bunch. We put it in the software and it all worked. And then you get it back, and then your aluminum piece has a bump on it. When the guy was putting it together, he was like, and then it goes in there. So now your aluminum was too soft, some details like this you're only gonna see in the factory. And sometimes you try to create a process, say no, I still wanna use that aluminum block because I ordered 20,000 of them before I did this, So I had to make sure it works. So then you have to actually make sure that the guy that's gonna put it in, he's not gonna do that. So then you actually have to improve your process so it doesn't matter who is actually the guy doing it. It's always gonna be perfect. Let's say if we go back into the measurement and I say if I leave my pencil here and my ruler there and we don't move it, it's not that I get it and we switch hands. I glue this down and I put a thin line on that side, like a little string. Then now this next person is gonna be able to, I can see this string and the string is parallel, right? Or perpendicular in this case. But then it actually helps the reader to make the reading, right? When sometimes you actually have to go very into what's the process, so you make sure that even though this maybe wasn't the best, would still work for you. So, and this is actually the main reason why things from China, they're good and bad. They're either the best things or the worst things. Because when you send something to be done there, you don't know how it's done. But how come the iPhone comes out or all the phones come out and they're good? Just because the company spent a lot of time just making sure the process is good, to the point that it says, on this one, this person only pushes one button. And there's a thing that doesn't allow the person to push it twice, And there's a thing, it's you keep putting a more process, a management there. Now I have two people to do it, Or because you can add more processes and the cost doesn't change because the cost of a production there is low, It changes, but it changes so little. But I used to work at design washing machines for Whirlpool. So this is actually what we spend a lot of our time trying to figure this out. And this one doesn't have anything different than the other one. But very good. That's it. Anybody have any more questions? All right. So for next class, now we're gonna already start doing the labs. So the first one is gonna be the demonstration. So everybody comes to this one, right? We're gonna try to organize the lab in a way that you guys have the chairs there. We're gonna post some information about the class. So if you wanna look through, most likely there's gonna be a PowerPoint, pointing out, let's say if you're on the vertical mill, there's gonna be kind of a drawing with what things are. And this is where you adjust the Z, this is where you adjust the Y, the X, this is how you lock the axis. So if you wanna, but I can send an announcement saying, please review this one. It's the change that we made is so if you are to be on the vertical mill, you watch the vertical mill. If you are to be on the lathe, you watch the lathe one. And if you are to be on welding, then you watch the welding one. So that means that we actually have to split now, right? Otherwise, how do you know where you are? So, who thinks that they have a shoe that's good enough to do the welding?
Yeah. We're not like that.
Elegant.
Yeah,
What
for
about
the
the work
boots.
shoes or boots or?
Yeah.
There's no boots would work. Kind of like off season. All right. So 1, 2. I do one more, so split in 3.
I can do it, yeah.
All right.
I have shoes off
All right.
Your boots.
my boots.
All right. So I need names. So in welding, it's gonna be
Carter.
Carter.
Cliff.
Maria.
Marie. And then now we have vertical mill and lathe. So now we can just throw names in there, right? So this is gonna take. That's the correct thing. Just gotta-
Basically, you make it back into a twist it, and get the other side to do the same thing, and you stretch it together, and then put a new piece.
So let's see, we're gonna be there 1, 2, 3, 4, 5,
And then
6,
hit you in the nose.
7. So we're gonna be like, each group is gonna be in the station for 7 meetings. Right? So 7 days, either you're gonna be in welding or you're gonna be watching something, but like you're gonna be in the group, in the welding group, or you're gonna be in the vertical mill group. So you have pretty much like everybody else would have 3 weeks and a half, 4 weeks to figure out what they're gonna use as a shoe when you guys go welding. Right? You guys understand what I'm saying?
That's what I'm saying.
Because everybody's gonna have to go in there eventually.
I have work boots for labor.
So we should bring the boots and stuff next class then, because we're going in.
Yeah. Yeah. So let's
Walking
see
in
what's
with
the.
I have my work boots. My work boots from this summer.
I'm gonna go buy some.
Because I was on the construction site.
Some
Oh, yeah,
steel-toe
you-
boots.
Yeah, you can have like a work boot for the summer. That would work.
I'm gonna go buy
Let's
some
see what's the
steel-toe
names
boots.
here. So
I
you
know,
guys
that's
know.
what mine are.
Yeah.
So you guys
What you
know-
should do is you should buy
Sign
some.
this or no?
Oh, yeah.
Where do you sign?
All right.
Do you just sign it?
So let's try Brett.
Brad's
Brad, vertical mill, baby.
Xavier. Aiden.
Let's go.
What's
Manel.
That's clean.
Do we make baseball bats?
My neighbor had a lake that my brother used to make
Wow.
outside his house.
I know you have a thing about pointing, so.
This is one time.
Yo, that's what we should do. Let's make a big, we'll do a big project at the end of the year.
All right.
I think we still have.
So
planes
make
for
sure
baseball.
you take notes of your group. And
Vertical
then
mill.
when we post the stuff, then you guys know what you should be focused on the next few weeks.
Where do you want us to sign?
Anywhere.
Just at the bottom?
Yeah, anywhere. I'm just gonna scan them all and just put it in there like that.
Who's Shin doing that? I want to do what Shin does. Like,
Number 3. Number 5 now. Number 3 and number.
Good stuff. So like expect when you go to modules, there's more modules are gonna show up here. There's initial meetings. Those are just 2. And then now we're gonna have late welding and vertical mill. Focus on the ones that you on your move, right? We're gonna try hard. The yeah.
Do we provide our own safety glasses?
No. You can come in. We're gonna have everything for you.
Sutras.
Yeah. And for welding, we have like a smaller gloves for girls, and we have like a different gloves, and we have the apron.
I have jeans too if you need any.
So pants,
I have jeans if you need any.
it says like a pants, but like a, if it's thicker pants, like a denim jeans, you know, it might work better than like pants like this.
No, I sweat. I'm gonna have to go buy some jeans now.
So like
So shooting sparks.
yeah, cause the sparks they actually so in welding, it's not uncommon that you decide to weld something like a kind of like a above your head. So let's say there's a lot of positioning with welding, so you position like this so you can do a good job, and then the sparks end up going on your skull. So it's not comfortable, but it's not gonna hurt you. So for those who are welding, if you have like a bandana, and you wanna put a bandana and then the hat, like actually all this guys that ride motorcycle, the bandana actually is it's a welder thing, but usually welders were also the guys that ride motorcycles. So that's why so they would use it, and now it's a thing, you know, it's a piece of clothing, but like that's where that little piece came from. So so if you I think I have one that I got for a student that she was like, you know, I don't have anything to put on my head, but like I don't feel comfortable in getting hit with the sparks. Then I have one. But like if you have like your own thing that you want to put on your head, then you can bring too. But yeah, that's the only detail about welding. The other ones like the other stations, there's not much that go with it, besides like I don't know how the professors are gonna do it, but like there's always like on the vertical mill, there's always a way to shoot sparks the other way, like shoot the shavings in a different direction, you know, because like you guys, like for those who are gonna be there, just like this is just like a tip. So like there's the bed, you know, where you put so like there's a vise here. You're gonna put your block in there, and then there's a handle here that you can actually make this guy move in that axis, and there's a handle there. And actually both handles do the same. So if I'm moving this way and start shooting stuff on me, I can just go to the you know. The same way, like there's another handle here that's gonna make this axis move. So imagine like I'm gonna try to cut this piece here right on top, right? But I'm only gonna actually flatten the surface here. So I'm just gonna flatten the surface here. We have the cutter, the end mill, and I'm moving this guy back and forth, right? So I can cut. This one, there's only one handle. But if it doesn't, why don't I actually, instead of moving like this and hold this, I move it like this and I hold it from there, you know? There's always a better way, like there's always a different way of doing it. So you can choose to do it, but I don't know how the professor is going to do it, but like this is actually things that you can think of, you know? I'm prepping. And then you can see what on the lathe, I think it's pretty easy. On the lathe is when you're using the auto feed on the lathe, if it's working well, if the machine is working well and the cutter is working well, you're gonna get like instead of actually getting like a shavings, being shot out, it's gonna make it like just a long piece. That's gonna start coming out of the thing, right? Same as like I try to peel like an orange, in a way that our peel is perfect. You're gonna be able to come out and have just a big long piece, right? This is not safe. If this get on your arm, and for some reason somebody pulls this, there's just gonna be like a knife.
Paper cut.
So usually, if this is actually making a long thing, just watch for it, because like sometimes they're like, oh, this is so fun, and like you forget about that's like this is just a piece of metal. They're like and somebody might just pull it, or it might get caught on something, and now it's gonna pull it, So just watch for. I think this is the only thing that I can remember that on the lathe it might be something to watch for, because even if the cutter breaks, it doesn't wouldn't hurt anybody. And I might make a video just to actually make sure. So we're gonna try to throw all this information out there, and then I can say, please watch this and watch that. I'm gonna watch what other professors have compiled to put there for you, just so we can all give you a sense of what I feel that's important, and Shaw is gonna show what he's gonna post to, so you guys know what he thinks that's important. So we're actually adding 2 or 3 professors what they feel that's important about this one machine, right? So it might be things that are a little different, but you get everybody's knowledge at the same time instead of just one person's. But good. If you guys are all good, I'm all good, and I see you guys on Tuesday. Close the shoes, pants. If you have thicker pants, that's better than soft pants. For those who are welding, if you have something to put on your head, we are not
I'm not working.
I'm gonna be the one welding, so the chance that it's gonna go on your head is small. Because it's just a demonstration day, right? All right.
Thank you.
Thank you.
All right. See you guys.
You're not gonna just leave it?